Otherwise, if we all get upset about the things that are bugging us, I mean, it's like, you know. First of all, when you complain, no one listens anyway, right? So. All right, we are back. We are with some technical difficulties. We are COMP305. That's Game Programming 1 in the fall 2019 semester at Centennial. And today we're going to be talking about kind of an intro to Unity 2D, which we are continuing from last week, as well as a couple of tools that I recommend for GitHub, as opposed to just using GitHub command line. So last week we kind of touched upon like GitHub command line, but what if you don't want to use command line? This week you can use something called Git Kraken. So again, there's several UIs that you could definitely use, and let's go over them. So one of the UI options are source tree. So if we go to source tree, so there's source tree. This is a pretty popular one we talked about, where you can download it for free, and what it does, it gives you a visual representation of your commits. That's what this part is here, and it takes the place of some of your commands you can do on command line. It's not bad. I don't mind source tree so much, but I find that between this one and desktop.github.com, which is from GitHub, right? They're not terribly bad. Both of them have their advantages and disadvantages. Again, this is one from GitHub, which allows you to do some of the commands you normally do in the command line here in the UI. However, I find the one that's probably the easiest to use is Git Kraken. And Git Kraken is also free, so I'd recommend downloading this instead. And when you download this thing, please follow the prompts. It'll ask you for permission to your GitHub account so you can make changes to it. When you do, you'll get something that looks like this. So here we go. So again, you can see that I have a couple of commits I'd made earlier today. This is lesson 2A. We're going to do 2B in a second. And you can see it keeps track of all my commits on the master branch. If I had multiple people, or if I had additional branches, it would show this in a visual representation here as well. Okay. So how do you do it? Let's suppose I want to make a new repo on GitHub. I can just choose on GitHub. Again, I'm just making a new tab here. When I click on GitHub, it'll ask me to select my account. Let's suppose it's Centennial, and I put a name like COMP305 in the fall 2019 semester and lesson 2B repo demo, right? Because there's a couple of them. You can see I want to give it public or private access if I want to pay for it. I can clone after init, which allows me to create a local repository on my machine after I initialize it online. And then you can see where am I going to clone it. Well, not Unity projects. I want to clone it in somewhere else. Let's talk about maybe on the desktop. I have this Centennial repos link, which is where I want to put it, I suppose. Now this is the cool part. Take a look at the git ignore templates. It has a bunch of them, and one of them is Unity. So if I type in Unity, it has a nice git ignore template just for Unity, and I think it's required for us to use them because otherwise we put too many things up on GitHub. It would actually not work properly. The things we always want to avoid when it comes to Unity and putting stuff on to GitHub is the library folder and the temp folder and the builds folder and a bunch of other stuff. And what the git ignore files do is it prevents us from doing it by accident. So I'm going to click create repository here and clone. And what this is going to do is it creates it for me on GitHub. If I click view on GitHub, you can see now that up on Centennial, I have another repository called COMP305 F2019 lesson 2B repo demo. One thing to note is the git ignore file. If you actually look at that, it's quite good. So what it does is it says library, the / and then square brackets, and then the capital L, lowercase l. That's again pointing to any L, lowercase or uppercase, in library. In the library folder is what this is saying, right? Same thing for the temp folder, the obj folder, the build folder, the builds folder, the logs folder, the memory captures folder, and so on. Other things, never ignore asset metadata, because if you put this in, what it allows you to do is your assets aren't missing sometimes. That's what happens when you put it up on GitHub. It ignores certain metadata, which is bad. Other things that you definitely want to remove are your .vs folder, which is your Visual Studio cache folder, and pretty much most of these. All right, you definitely want to keep all that stuff. Remove them. And then these ones are all to do with little database files that Unity generates when you launch, so you can get rid of all those too. So why are we doing this? Because if we have a gitignore file, instead of putting a bunch of garbage files up on GitHub that are not required, it only puts the bare minimum package up on GitHub, which makes your pushes quicker. And also when you pull it, and let's say you want to go back or give it to somebody else, you want to share your repository with somebody else, then it works nicely for them and doesn't mess things up for you. Okay, so that's Git Kraken, right? And we'll do more Git Kraken today. All right, and I recommend this for people who are not interested in command line. Not everyone is interested in doing that, and I find that it's a good alternative to using the command line. If we talked last week also about GitHub Educational Pack, let me just go back there. So if I say education.github.com, and if you go to GitHub Student Pack, which I shared the link for you on week 1 on eCentennial, you'll see that it also includes, if you scroll down, kind of the free pro version of Git Kraken for a year. So if you sign up for the educational pack, you get this. And you also get something called Git Kraken Glow, which is another tracking software for your project. So again, popular tracking options that we've seen before, and I've mentioned I think last week, are GitHub projects. That's one. The other one would be Trello. Another one would be Jira, and I recommended Jira as if you want to have a good interview, let's say with someone like Ubisoft or anywhere else, any professional area institution uses Jira these days. That's a good option. But also the other one that's integrated nicely with Git Kraken is something called Glow, which if you go to Git Kraken and try and see what's new, Glow boards are very similar to, let me go back and try that again. Glow boards are very similar to any other kind of Kanban board. As you can see, they're pretty good, and they also have dark mode. So that's something that you might be attracted to if you wanted to try tracking your project by using your version control tool. Okay, so that's it. So questions around Git Kraken? I just wanted to make sure that you had another option to put stuff up on GitHub as opposed to using strict command line. Okay, so that's that part. We also talked before the recording about your different project parts. The contract is due tonight. I'm just going to bring up Unity as we're talking, so I'm going to go to Unity Hub. The other thing that's due is a lab that is basically going to show you, show me that you know how to do stuff on GitHub. For anything that you want to share with me, you can give me links. Like some people don't want to use Microsoft Word, they want to use Google. I'm perfectly fine with that as long as I have access to those links. If the links are dead or I can't access them or they're moved or something, I can't give you marks for things that I can't access. Okay. Any submissions to me again will be through eCentennial. There's no paper in this course. It's all through the eCentennial system, which is Desire to Learn. Alright, so what I want to do here is I want to talk about how to do a project again with Unity. So let's launch Unity here. I'm going to click New under Unity Hub. Again, from my install perspective, I only have one install, which is 2019.2.4F1. If you noticed lately, there is another one, which is 2019.2.5F1. However, I'm asking you all to stay with me on the previous version for now. There's not much change. And so that would be the stuff that we do together shouldn't give you a problem. If you want to find my version, just go to the download archive, and if you scroll down, you can see that 2019.2.4 is here. You just add it to Unity Hub, and you can download that version as opposed to the latest one. Okay. And you're going to say, well, why don't we use the latest one? Well, because they're going to keep having a latest one every month, right? So we're just going to stick with one version until the end of semester, and then next semester I'll switch to whatever the newest version is again. Okay? So that's that one. So I want to start a new project. So I'm going to go to Projects here under Unity, and I'm going to click New. Again, we're going to click on new 2D project. We kind of started this last time, but I'm going to start it again this time just so you can see it again. So COMP305 in the fall 2019 semester, and it's lesson 2B. Again, this is going in my Unity projects folder, and I'm going to click create. So after we wait for Unity to launch, which shouldn't take very long for you guys, we're going to bring this up, and we're going to be working with Unity for the majority of the time. Okay, cool. So here's Unity. Again, if you notice, I'm using my layout, the one I like to use, but again, you can use whatever layout works best for you. I was making just some recommendations last time. So again, what I like to do when I go into Unity is set up my folder structure like we did last time. So I'm going to do it again one more time, and I'm also going to put it up on Collab and share it on GitHub. Right, so I'm going to do all those things with you in a few seconds. Let's try this out. So again, I'm going to go to assets, scenes. What I normally do is I add in an underscore for scenes. So again, I'm just going to rename this thing underscore scenes as opposed to just scenes. I'm going to add in a new folder for scripts. So again, I'm going to kind of type in underscore scripts, and then models, if I'm going to add any 3D models, sometimes even 2D models, textures, for any images you want to use, materials, animations, fonts, prefabs. Right, I think that captures most of it. And the other one I also like to add in is imported assets. And what I do with that one for imported assets is anytime I download something from the asset store, I pop it in there. I kind of move it in there, so that way it doesn't pollute my kind of the root folder of my assets. Okay, so that's really my folder structure. I also changed the actual active scene. So right now the active scene is this sample scene. So I could double click in there and then change the name of my sample scene to main, which makes me reload. Okay, so I think that covers most of how I start off. And now I have a structure that I can use. Are you with me? Just these things. So some things about this, okay? Now I want to put it up on Collab, and like I talked about before, the Collab button is right here. Everyone has access to that. You have free access to Collab for up to 3 users, right? And what Collab allows us to do, like we said last week, is you can use a type of version control through Unity's cloud, where you can post stuff on Unity's cloud. I believe the free version allows you up to 2 gigs of shared data between you and others for a particular project. Actually, for all of your projects. However, if you pay $10 a month, for every additional user beyond 3, if you want to go 4, 5, 6, it's $7 a month in addition to that. But you get 25 gigs of space for Unity Teams Advanced, is what it's called. You don't have to have the professional version of Unity to use that. And like I told you guys last week, it's something that's very convenient. I've been using that over the last year or so. All right, so I'm going to just add myself to Collab. So I'm going to click on this little Collab button, which is going to say Start Now. So I'm going to click this button. I recommend you do that as well. And then what it's going to do is going to say, okay, well, what organization do you want to use? And I'm going to use mine, so it's me. And then I'm going to click Create. And what this does is it creates a cloud-based project that I can access. Now, if I scroll down, I can turn on Collaborate. See this? I can turn on Collaborate. And what this allows me to do is if I want to collaborate with one of you, all I have to do is basically add you in as a user. Okay, so that's what I did. I've just collaborated. But notice that all my folders now have this blue plus next to them. And that means that they all have to be pushed up to the Unity cloud. So I'm just going to go to here to collaborate, and I'm going to click, base project. I'm going to add a little comments, right? And click publish now. And what this is going to do is going to take my current project and push it to the cloud. So wherever I am, with Unity, I can always pull it back down. One thing to note also is it tells you this little icon down here allows me to view the history, and you can see that I've added 10 assets to my history. Okay. Also, up on eCentennial, if we go to eCentennial, please let's go there together. Under on the bottom, there's a few links I've added in. One of them is Mail Pilot Assets, and we're going to do a bit of a demo today. So I want you guys to download Mail Pilot Assets. There are a few images and fonts, and one font and some audio assets. I'm going to do that to show you what they look like right now. So if you go to the assets, be nice if I went to the right folder. Then you can see that you have a couple things. You have audio, a few OGG files for audio. You have fonts, one font, and you have images, which are all the textures that I want to add in. I gave you guys that all up on eCentennial. And what you want to do now is drag and drop those things into Unity. So let's see what I'm talking about here. So again, a couple ways you can do that. You can just make Unity a little bit smaller so you can fit both screens on your desktop. I mean, again, I'm kind of just broadcasting, so it's a little smaller than normal. But if you look at audio, let's go to audio here. And do I have an audio? Oh, I forgot that. Let's add an audio folder. I forgot the audio folder. Audio. So in the audio folder, I can drag and drop my stuff in the audio folder of my file explorer. If I just drag and drop here, Unity converts it into something that's usable. Okay? And I can do the same thing for the rest of the folders here. I have a fonts folder, and I have a fonts folder here, and I can just take this Doc51 font and drag it into Unity. And finally, I have a textures folder here in Unity, and I have an images folder here on my computer. I'm going to take all the images that I've kind of given you and just drag and drop that into Unity as well. So now you have all the assets that I'm going to be using for this demo this week and next week. Okay? And it's kind of some old assets that I've been using for several years. And again, it's just for demo purposes. So I've got these assets now. I've added them in. You know what? I'm going to do another push to Collab. So I'm going to go to Collab. I'm going to say added game assets. And then click Publish Now. And what this is going to do is going to push everything back up to Collab. And you see it's like 1.5 megabytes or whatever it was. There we go. It's all done. So now my little... I love my green check mark. I can tell you, every time I see a green check mark on Collab, I'm like, yo, yay, it's good. Okay, but now what I want is I want to close down Unity and put the whole Unity project up on GitHub. Okay, so I'm going to close down Unity. And I kind of had a challenge with this last time, but let's see if I can do it with GitKraken this time. So, again, I have GitKraken. I'm just going to just close down some of these tabs. I'm here on GitKraken. I'm just going to use a non-command line based option here this time around just to see how it goes. So I'm going to click on, again, so if I start a local repo, that's a brand new repo. I can open a repo. I can clone a repo. I can host a repo on GitHub, right? That's pretty cool. I can do that. So if I start a local repo, the biggest problem with that is that it creates a new thing, and I can't open a repo that doesn't exist. So part of what I need to do here, which is kind of a weird thing that I can't just initialize a new repo in a folder that exists, right, is I have to go to command line for 1 sec. So command, and I want to navigate to Unity projects on my desktop, and then Unity projects. There we go. In my Unity projects, I have my new project, so COMP305 2B. And what I want to do is initialize Git. And the way to initialize Git, first of all, you have to have it installed. And kind of like what we talked about last week. So in order for you to make sure that this is installed properly, you need to download Git from a location called git-scm.com. Right, git-scm.com allows you to download the latest version of Git for Windows. If you download it from there, I'm going to put that link up on Discord. So we have our little Discord channel that was kind of failing us today. I'm going to put that in general. So here's git-scm.com. You guys can try that on Discord. So if you grab that, yes, we don't have a bot command channel. Sorry, but if you grab this this link, it'll give you everything you need to install Windows locally on your machine. That's our Windows. GitHub locally on your Windows machine. That's what I meant. Yay. When you do that, you'll have access to do this. I can say you should be able to do git -- version. If you can do git -- version on your command line, then you've installed things properly. And how do you get to your command line? If you go to your little window here on Start, and if you just type in CMD and press Enter, you'll kind of start a command line. Are you with me? Now, if your command line is not working and you're going to get something like unrecognized command for Git, you need to install Git local in your machine from git-scm.com. So if it works, I can do something like this, git init. And what this will do is it'll initialize my Git repository. One thing that I'm missing, though, is a gitignore file. That's one thing that Unity doesn't automatically do for you. So I know we have a gitignore file that we've already pre-generated because up on GitHub, if I go to GitHub, let's go there, here. And if I go to Centennial College, here it is. I've actually put up this repo demo. I put two, one from this morning and one from today when I was demonstrating Git Kraken. So if you actually go to my GitHub, you can see that I've got this repo here. And if you scroll down, you see this gitignore file. Well, this is the gitignore file that I want, this detail gitignore file in my local repo. So one of the ways you can create this, right, is on the command line, you can just type in touch and then .gitignore. And again, this works for PowerShell nicely. And so it creates a blank, it'll create a blank .gitignore file. There's nothing inside of it right now. And what I need to do is just go locally. So I'm going to just search for this locally. So I'm going to go to my desktop where I have my Unity projects. Look inside my COMP305 F2019 lesson 2b, and then double click on my gitignore file. And what that will do is it'll just produce it as empty. So what I could do if I don't have access to one locally is I can go one here, and I can look at raw up on GitHub here, select all, copy it, and go back down to my notepad and paste it, and now I have my entire gitignore file here locally. I don't need all of this, however. I mean, I know that it includes things like TextMesh Pro and auto-generated JetBrains Writer plugin, ignores, and everything else. I don't need all of this, but I'm just going to accept it. I'm going to probably just, Control S to save, or file save is perfectly fine as well. And this will give me the gitignore file that I need locally. So why do I need a gitignore file? If I don't have one, then everything will go up, including the stuff I don't want to go up to GitHub. I don't want everything to go up to GitHub. I want to limit what goes up there. Other things to note: if I put empty folders up on GitHub, if I push my project, will the empty folder show up on GitHub by default? No. You need to use a Git Keep file for each of those. So we know a bunch of folders don't have anything in them. Like, for example, we don't have anything in models, we don't have anything in prefabs, we don't have anything in audio, we don't have anything in a lot of those folders. So I want to add Git Keep just so I can maintain my structure in all those folders. So I'm going to go and do that manually. So I'm kind of do a directory, and I'll go into Assets. In Assets, I want to go to Animations. I know I don't have anything in there, and I'm going to say touch.gitkeep. Touch, again, just creates a file. I'll go into the next part, Audio, and then touch.gitkeep. And again, GitKeep just makes it so that it'll go up on good. So I just wanted to check that. The other part is imported assets, and then touch.gitkeep. and we'll go to materials, and I'll do the same thing. Just a bit of prep, that's all it is. Models, and prefabs. And we still have scripts too. No. I think so. I covered everything. I think I got everything here. I think everything has a .git keep file. Now that I'm ready to not use command line, even though I've been using command line for everything else, let's suppose I don't need it for Git Kraken. I'm just going to go back up here now to Git Kraken, and I'm going to click on open a repo. So if I click open a repo, I can open a repository, and what this allows me to do is pick a repository from a folder. So I'm going to go into my lesson 2B folder that I just made, and I'll pick this folder and press select folder. And this is going to say, okay, hey, you must have initial commit to be open. Do you want Git Kraken to make this commit for you? Sure, initialize. And so now that's all that it's done. All that it's done is made an initialize command. One thing to note is, even though I've initialized and I've done this, right, Git Kraken is still not ready to connect with anything. I don't have a remote. Okay, so the remote, one thing I want to do is add a remote, and there's 3 different ways to do that. One of them is to go to GitHub and pull down something, and sometimes what I get is something that looks like this, which is no good. But I can go to my URL, and what this requires me to do is go up and create a remote like manually on GitHub. Let's do that now. So again, back on GitHub, I'm going to make a manual repo by clicking this button, and I'm just going to make this manual repo COMP305 F2019, and then it's going to be lesson 2B. Just press enter, and I'm going to get this little link automatically when I do that. I'm going to copy it, I'm going to go back to Git Kraken, and I'm going to paste it in, and I'm going to call this same name. So same name. I'm going to add the remote, and there we go. So my remote is added, which is important, because without the remote I can't do a push or a pull or anything like that that's up here. Okay, so that's the first thing. So again, that's what I'm talking about there. Now, it's almost ready to go, and I'm going to reload this. So it's going to basically, what it's going to do is going to refresh everything. And now when I go back to open up my repo, you can see that I have everything connected. It just needs to be refreshed. Okay. So this is lesson, that's the wrong one. Let's try that again. Open a repo. Recently opened. I want to do this one. Let's check, choose the wrong one. Is that 2B or 2A? That's 2A. One more time. Open a repo. Recently opened. 2B. Okay, I don't see it, so let's go back and find it. That's weird. And again, guys, you know, I'll tell you, I prefer by far to use command line. It's just more reliable for me, but this works too. Okay, so this is cool. You can see that I've got 71 changes, because what this did is only made an initial commit with the README file. Now, what you can do with Git Kraken is literally stage all changes. And what staging does is it selects files inside your folder. You don't have to select every file to put up on GitHub. And so I want to stage everything. So I want to stage everything. Everything now is in the staging area. You can also unstage certain things, which means I don't want to select certain things. Deselect is really what it is. And then down here in the commit message, I can say something like added assets to project. And then click commit changes to 71 files. That's my new commit. And I can then push the commit using the tool up to GitHub by clicking the push button. Must have a remote. I thought I made a remote, but maybe I didn't. Yeah, that was weird. I don't know why this happened. This is what I'm saying. So this is where you know, it makes me angry. But whatever. Add a remote. Push to the remote. Sure. And we're good to go. Okay, fantastic. So yeah, that's the ease of use that I was talking about. So easy. I'm being facetious. I could have done this like in 2 seconds on command line, but I want to show you an alternative for people who don't know. Okay. So I'm just gonna you know, kind of minimize this, and you can see up on GitHub now we have 2 commits and we have all my stuff. If you look at the assets folder, I have all my folders because I put the Git Keep file in there. So it retains my folder structure, which is what I wanted. Okay, back to Unity. Let's get back there. So we did that part. I want to go back to Unity Hub and I want to relaunch my project. So here's 2B. I want to launch it. And it does a little bit of quick kind of checking to see if I need to re-import everything, and it doesn't, so I'm back up and going. And I'm ready to go. So we're going to start off with the scrolling idea. So how do we create a scrolling object? Again, for those people who know how to do this, please bear with me. I'm going to go slow because I want everyone to be on the same page when it comes to how to create a scrolling object on the screen. And what I mean by that is something that moves and is an endless scrolling object, something that doesn't stop scrolling. So we have inside your assets an ocean object. Now let's click on there. I'm going to go into more details about each of these things. Note that when I click on the ocean texture that I've given you, on the right it shows a piece of information, and one of those pieces of information is Sprite 2D and UI. This is good. This is identifying this ocean texture as a sprite. The next part is sprite mode. There's different options here, single or multiple. Single means it's a single sprite. Multiple means it's a sprite sheet. That's what it is. Okay, so you guys should know that. So what does this pixels per unit mean? Anyone knows what that means? Anyone? Pixels per unit. What does that mean? So why do I have that? Yeah. No. Not exactly. Anyone else have a good guess? How about you guys? In the green table. Any idea?
How detailed is the image going to be?
Not detailed necessarily. It's not just quality. It's close. You guys are skirting around it. So what it really is I have a regular image, right? And what's happening is the image is being scaled by Unity. So Unity is taking it and saying, guess what? My ratio for how many pixels I'm going to assign to each Unity unit, and what are Unity units measured in? Do you know? Meters. Meters, because Unity is a 3D game engine, right? And remember what we talked about last week. This is, even though it shows us that it's 2D, it's actually 3D, right? So if I click on the camera, the main camera, it looks like this, right? This is not really 2D, but what Unity does is it has a 2D or orthographic projection. That's what's happening right now. And also we talked about last week that main camera that has 0.3 to the near plane and 1,000 to the far plane, that's really overkill. You don't need 1,000. You can even go down to something like 10, and that's totally fine. Like a smaller box, which means less calculations, less things to keep inside of your in your frustum. Okay, so that's this part. So going back to that, then, if I go back to 2D, you can see that it looks like it's perfectly flat, but actually it's the projection that we're looking at that's slightly different. Okay, so and back to the ocean, what I was asking is, what does this pixels per unit mean? Well, if this is in Unity units, that's what this is, right? Then what it does is says, okay, for every Unity unit, I'm going to assign 100 pixels from the image. So I know that the ocean image is 640 pixels wide by 1440 pixels tall, which means we're going to have 14.4 units for the entire image, Unity units, and 6.8 Unity units wide. That's what's going to happen. So when I drag and drop this object, the way you put this object into the hierarchy is you just drag and drop it. When you drag and drop it, you can see that a couple of things happen, and some of them are not welcome. For example, I've got my ocean in here, but the ocean is actually kind of in the middle of the screen. And you can see the viewport here. This is the viewport. If I look at the game, it's actually going to see these like blue bars on the right and left, because guess what? The viewport is larger than my image. Now there's two options here that I have, what I can do. One, I could scale my image to be the same size as my viewport. Or I can scale my viewport to be the size of my background image. I'm going to choose the latter, actually, in this case. Let's keep going with the ocean bitmap for a second. So one thing is, the pivot by default is the center, right? That means in the exact center of the screen is where, when I grab this image, and if I click the W key on my keyboard, again, I can control Unity by the Q key, which is kind of this little hand, the W key, which allows me to move my object around, the E key, which allows me to rotate my object, right? The R key, which allows me to scale my object. It's QWERTY, right? Key W-E-R-T, like that. So those are the buttons by default. Well, what I want to do is notice that the middle of the image is where I'm allowed to move it around from. I can use these control handles, right, to move my object in the X or Y plane. That's what it allows me to do. So, okay, that's interesting. Again, going back to my ocean, but the pivot is showing us in the middle. If I change the pivot, by the way, to the top left and click back and apply the differences, you can see now that not only does the control handles appear on the top left, but the 0, 0 point, the local 0, 0 coordinate point for this object is the top left corner of the object itself. That's what it is. Let's take it back. Let's take this object back to center. All right, so again, center is the default. I'm going to click apply down here, and it puts the object back in the middle of the handles in the middle of the object. Okay, so things to note. So when we move things around and addressing the object, when the object gets physically dropped onto the scene, the 0, 0 point is in its exact center, because that's how we've configured it. Or we've left the configuration to the default configuration, which does that. Okay? So that's pivot. Also notice below, it has a compression ratio, or the way it's going to stretch or change the aspect ratio of this object is down here. So one thing we're not doing this week is creating a pixel perfect game. All right, Unity, you can do that. You can change the pixel ratio to 1:1 as opposed to 1:100 like it is here, and then you can make a pixel perfect game. The challenge with pixel perfect games is they don't always fit in all viewports. The reason why they use 100:1 pixel ratio is so that they conform better to their unit system, Unity's unit system, and it works nicely with 3D. However, if you wanted to, and you wanted to make your game work on a particular device for sure, then you may elect to make a pixel perfect game, which means it's a 1:1 ratio, and you change all the textures to that. The physics, though, I have to tell you, really mess up when you do this, because physics run on Unity's aspect ratio. Okay, so that's one. So one is, we have to note this. The next part is, under our game tab, you can see that I have set up another ratio. There's two different aspect ratios you can set up. If you want to set up your own custom aspect ratio, because by default it looks like free aspect, like this. And sometimes I want to emulate what it's actually going to look like on a smaller screen, like 640 by 480. I can create my own. I can go down to this little plus, and then I can decide whether it's fixed resolution or an aspect ratio. I can label the new resolution, and then put width and height down here, whatever it is. In this case, what I did for 800 by 600 and 640 by 480 is I made, instead of an aspect ratio, I just use a fixed resolution. However, I could also use 16 by 9, right? Here's an example, and I can scale this all the way back so you can see the black bars on the top and the bottom, letterbox, right? But what I really want to do is fit this thing into 640 by 480. So I'm going to click on 640 by 480. Again, you can make this. It doesn't exist by default. So now I have 640 by 480, and notice that my ocean is like not as big as the rest of my object. Why? Because of my main camera. My main camera, I talked about this last week, not just for the orthographic view, but also this thing called size. And if you look at it, it says the vertical size of the camera view. Vertical size, that means this way. So it's 5 units. But 5 units doesn't make any sense for us, right? Remember that the vertical size that we have, right, is 480 pixels. 480 pixels. And what I want to do, it's 5 units from the center. The camera measures 5 units from the center. If I want to make it proportional to what I have in my background, which is 640 by 480, I need to reduce this size to match half the height. So half the height, if my height is normally 480 pixels, and if we have a 100-to-1 ratio, that's 4.8. And if we take that 4.8 units and divide it by 2, then, well, that should be 2.4. Let's try this out and see what happens. So it's not quite right. Now you can see that there's a bit of it's a bit off, but take a look at the scene. So too is my scene. It's a little bit off, right? So if I take my ocean and if I move it around, so if I take my ocean and move it, you can see that I have a position on the y-axis of 0.2. I can put that at 0, and I have my position on the y-axis. So the x-axis is 0 and the y-axis is also 0. It centers everything, and now that's perfectly centered in the screen. But I did have to change my camera's size to 2.4 to make this work. Okay, so what do I want to do here? Why am I doing this? Right? Because I want you to think of it this way. I'm going to have a scrolling ocean, right? Undo. I'm going to have a scrolling ocean. So the viewport's going to stay stable, but the ocean's going to start like this. Okay? Take a look here, guys. And what I'm going to do is I'm going to scroll the ocean down slowly, right? And as the ocean gets to the top of the screen like this, as soon as it gets to this point, I'm going to reset. And it's going to keep going back like this. And it's going to keep going down like this, and it's going to reset. It's going to reset so quickly that it's going to look like it's a continuously scrolling ocean, or endless scrolling ocean. Are you with me? So that means it needs a reset point. So by default, you can see if I kind of put this where it's supposed to go, it looks like the reset point is 4.8 units, or meters if you will. 4.8 meters is where the reset point is going to be. And then it's going to scroll down. I'm going to change the ocean object so it's capital O for ocean. Let's do that. And the ocean object, like every other game object, has a transform component. Right? So every game object in Unity has a transform component. It includes position, rotation, and scale, which we talked about last time. It also has something else. Anything that I'm going to draw on the screen has something called a renderer. In this case, because it's a 2D object, it has a sprite renderer, right? And the sprite renderer basically is a process, a piece of code that basically tells Unity that I'm going to draw the ocean texture wherever my ocean game object appears on my screen, according to the pivot that I've assigned for that particular object. Alright? So basically, I can make my own game object from scratch. Right? I can make an empty game object if I wanted to try this. So make an empty. So let's say call it game object. By default, again, I have my transform. And if I reset this to the 0, 0 point of the screen, and then I add my own sprite renderer to build it up. Let's see how that works. If I just typed in sprite renderer, right? My sprite renderer is empty, right? And let's just hide the ocean for a second so you can see what I'm talking about. So right now it's just an empty object. Here's an empty object, and I put a sprite renderer manually on there. And then if I point to the sprite that I want, for example, the ocean, you can see that it immediately does the exact same thing. I built up my ocean manually, as opposed to Unity doing it on its own when I dragged and dropped. Again, I have two components now. I have a transform component and a sprite renderer component. Okay? I'm just going to hide this game object for now. I'm going to come back to it in a bit, and I'll talk about why I need it. Okay? But let's go to my ocean again. By the way, notice that how I hid, and I can hide and show objects by using this little checkbox. You should know how to do that. Alright, cool. So this is where my ocean object is going to be, and what I want is when I start my game, my ocean is going to slide down until the top of my ocean for now, which is this part right here, meets the top of the viewport. When that happens, it's going to reset back to here, over and over again forever. This is behavior. And for behavior, I need scripting or logic. Okay? And what I'm going to do here is I'm going to go to the scripts folder, and I'm going to add my own new script. I'm going to right click here. I'm going to say create new C# script, and I'm going to call this ocean controller. Other names that you can use are ocean behavior. Right? Sometimes people use ocean behavior instead of ocean controller. I like to use controller. Okay, cool. Now the ocean controller is not attached to the ocean at this time. Okay, I can do that by clicking on the ocean once. In the inspector, you can see that there is two components, and if I drag and drop the script for the ocean controller onto the ocean game object, then what happens is, let's try that again. Then what happens is I have another component. I have a third component. 1, 2, 3, and my third component is the ocean controller. Right now the ocean controller doesn't do anything, and if I double click onto it, it'll bring up my default editor. For me, it's Visual Studio 2017. For you, it might be VS Code, which is perfectly fine, or Visual Studio 2019 at this point. Whatever you decide to use, and there's other options you can use. Alright, so here's my ocean controller. Notice that it inherits from mono behavior. Mono behavior is the default. Why? Because fixed update uses a fixed step in terms of when it gets called. And we'll talk about the Unity lifecycle maybe next week. I've put up a PowerPoint presentation that basically talks about the Unity lifecycle, which shows which of these events, because update, think about update as an event that's being called, which event gets called and in which order. Okay? So I want to kind of, control the behavior of my ocean. So let's think about this. So I want the ocean to move down. So in order for me to do that, I need some kind of command to make that happen. I know, going back to Unity, that the transform component on my ocean contains a position function. And what I can do is I can change the position of my ocean every frame. Some number of units, Unity units. And I want to move it from here, which is at 4.8 units, I want to move it down like this to a negative 4.8. And you can see I'm just not hitting the mark, but I can just put it in manually. I can just put negative 4.8. So that's where I want it to go. And when it hits negative 4.8, it's going to reset back to 4.8 again. That's what I want it to do. So 4.8 units is the magic number for now. We're going to change this later, of course. So I want it to move. And certainly I can put it in here. I can put it in some command in the update raw, but I think it's bad form. It's far better to put it into its own function. So let's do that. So I'm going to say void move. And in the move function, what I want to do is I want to affect the transform component. The transform component is available just by typing transform. And it refers to the object's transform that this script is attached to. Right? So transform dot. And then what you want to access is the position. So this is the position of the object. The global position. Right? Now here's what I can't do. I can't say the global position.y is equal to something. Like for example, some floating point number. It won't allow you to do that. Unity exposes .y and .x, the two coordinates, so that you can read from them. So it's a getter only, no setter available. Right? So in order for you to set the position, you need to create or add a reference to a vector. So again, Unity comes with several different kinds of vector. There's vector, vector 2, vector 3, and vector 4 by default. Vector 2 means x and y coordinates. Vector 3 means x, y, and z coordinates. Vector 4 means x, y, z, and w components, where w is the imaginary number. Alright, so let's go back to vector 3. So I want to add a new vector 2 object. That's what I want. And my vector2 object is going to have two components, x and y. I don't want to move anything on the x-axis. I just want to update the y-axis. So what I want to say is 0.0 f on the x-axis, and on the y-axis, I want to somehow add a value. Now I can certainly type in a hard-coded value in here, but that doesn't make any sense. I want to have control over what value goes in there. So let's make another value. I'll leave that like this for now. And I'm going to go up underneath the class and put in a public property that I want to call vertical speed. So again, it's of type float, let's say, and it'll be called vertical speed. And I'll assign a temporary value to it. I'm going to say that the vertical speed is 0.1 f. So why 0.1 f? What does that mean? Well, if we go to the ratio that we were talking about before, 100 pixels per unit, then 0.1 f is 10 pixels. 10 pixels per unit, which means the vertical speed is going to roughly be 10 pixels every time. Now, I could say 10 pixels per frame, but we're using update. So it could be slightly faster or slightly smaller than that. And this might be too fast, I'm not sure. Let's take a look. So now that I have vertical speed, this is what I want to update my transform position. But if I make it equal to, it's just going to assign a value, the same value every single time. And what I can do with position, and they've overloaded it, so I can use the plus equals, or the minus equals in this case. So what I want to do is I want to subtract from the current position by subtracting a vector, which I'm going to use vertical position, vertical speed for. So what this does, without giving me this error, it says operator minus equals ambiguous on the operand of vector 3. So transform.position, I'm saying, hey, take this transform position and subtract a vector from it. And this would be nice if my transform position would do such a thing, right? Notice it has a get and set. But it doesn't like that. In fact, what you may want to do is something like this. Here's my vector 2. I'll call this new position. And that's going to be a new vector 2 object of the thing we talked about before. There we go. Okay, that works. And what I want to do is I want to take my transform.position, and then I can minus equals the new position. Again, it's going to give me the same error. So why do you think that is? Why is transform.position and minus equal new position not working? Anybody? So again, it says the minus equals operator, right, is what it is. Well, it doesn't like this kind of thing typically. What you have to do instead is do something that looks like this. So I'm just breaking it down to multiple lines, guys. You can do this in one line, believe it or not. Well, it's not. Let's just say let's say the vector 2 current position is equal to transform dot position. Let's just suppose. If current position is transform dot position, it gets a reference to that position. Now let's try that. If I say that, okay, very cool. Current position, can I do minus equals new position? Can I do that? How's that look? And that works. So first I get a reference to the transform dot position of the object, and then what I'm going to do is I'm going to subtract some new position vector, which subtracts the vertical speed from the current position, right? And now what I want to do is I'm going to reassign current position back to the transform. So I'm going to say transform dot position is equal to current position. And what this does is it allows my current position to be updated. Now, again, there's certainly other ways you can do that. I'm doing this so that everyone understands what I'm doing. So one, I've created a new position. Every frame, it's going to be x, and then whatever the vertical speed is, and I'm just making a reference here on line 24. Here, I'm subtracting my new position from my current position, and adding it and kind of updating current position, and then I'm updating the transform position to the current position that I just calculated. Alright, so this should move me down. And where I want to do this move action, and by the way, if you want to comment this thing, C#, remember, has the triple / commenting system. If I go // it creates a summary, and I could say something like, this method moves the ocean down the screen by vertical speed. Okay, and now I want, in my update, I want to call my move function. So what this is going to do is it's going to move my ocean down the screen. I don't have a check though to stop it, so it's going to keep going. Let me show you what I'm talking about. If I now go back to Unity, here's Unity, and I'm just going to zoom in. And again, just to make sure that Unity's the object is in their correct position. And if I press play, what we should see is this object is going to just roll off the screen and keep going forever. Let's try it. So run, and see you later. It's gone, right? Let's try that again. And let's take a look at it from the scene perspective. So what I'm going to do now is I'm going to just pause everything before I start, and then press play. And what this does is it's now in active mode. But if I go back to the scene, when I unpause it, take a look at the scene, what happens. It kind of runs off the screen. That's what I'm talking about. And I'll keep running off the screen forever, right? So what I wanted to do now is I want to create a check. So when the top of the ocean, like I said, hits the top of the viewport, it's going to reset back to this position. And the position that it's going to reset to is the 4.8 unit position. So let's make a variable for that. So we're going to say that a public float variable, which is the reset position, I'm going to put that so it's exposed on the editor, is equal to 4.8 f for float. By the way, whenever I do public something, then on the editor, as you can see in my script, you can see that these values are now exposed. I do not have to use serialized field. Serialized field, for those people who know how to do that, or what that means, is usually used for private objects that I can serialize. I can make them available in my editor here. So now, in my editor, I can change the reset position to whatever I want, and I can also change the vertical speed here on the fly. And I'll show you that in a bit. So I got those two values, and what I want to do is, so reset position is where it's going to reset, yeah? Let's go back down here and create a reset function now. So again, I'm going to make a function called reset, and my reset function is literally going to just say, my transform.position is equal to this new position, whatever that is. And I'll just copy paste. I'll say that transform.position is equal to a new vector2 object, and instead of m vertical speed, it's going to be the reset position. Does that make sense? So the position of my object, whenever I call my reset function, is going to reset to the reset position that I mentioned, which is 4.8 units to the top. Okay? Let's add some comments. // this method resets the ocean to the reset position. Okay, there we go. Let's try this out. What do I want? I want the reset to happen right on start. So on start, I want this thing to reset to the position. That's for sure. Let's do that. Okay, fine. So it resets on start. But what happens? How can I reset it after it gets to a certain point? Well, I need an if statement. I said whenever this object gets to a certain point, negative 4.8 units, then I want to reset it. I could put that in here, but every time I do something in the update function, it kind of pollutes it. And I like to keep my update functions and all functions doing one thing, as an example, as much as possible. So I'm going to make a new function called checkbounds. Now I've called them functions, but really you can also think of these as methods because they're part of a class. So here's my checkbounds function. And what my checkbounds function is going to do is going to check to see the position of the object, if it's on the lower bounds. And if it hits the lower bounds, then it's going to reset. So I'm going to say that if transform.position.y is less than or equal to And again, now I need to have that lower position, and I can certainly put a number in there, but that would be hard coding it. I want to put that something that I can play with up here in the editor. So this would be like so this is where it gets reset, but I want to detect when it needs to be reset. It's almost like the maybe reset point, which is something different. Maybe we can use another name there. For now, we'll just call it reset point. And that's negative 4.8 F. So at that lower end, the lower reset point. So again, I can say that if it's less than or equal to the reset point, and again, we should maybe rename those. If that's true, then what I want to do is I want to call reset. And this check bounce method or function is going to be called inside the update function. So once I move, every move, I'm going to check bounce. Are we good? Anyone not good? How about that? So again, move and then check, and move and then check every frame. Move and then check. Keep checking. And if everything goes well, then my friends, what's going to happen is this is going to hit a certain position, the reset point, and when it does, it's going to reset it back to the reset position, and then it's going to run down again, hit the reset point, and keep doing that over and over again. I'm going to go back to Unity and run this thing and see if it works. So when I run it now, let's see if it happens. So now it looks like it's running forever. And if you look at the scene, you can see what's happening. The scene is actually refreshing it over and over again. That's what's happening on the scene view. But there's a problem. And what is that problem? Maybe you guys can see it. Take a look at the game now. What do you see that's a problem? Take a look. There. 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 Yeah, it's a bit of a glitch, isn't it? Well, what's happening is, and this is the way my object was formed, the texture. The top of the texture and the bottom of the texture aren't perfectly tileable. There's a bit of a challenge, right? So the way to minimize this, to reduce this, instead of having just one ocean, we can have two. So this is where you do it. You go like this. You have one ocean, it scrolls down, and then you have the other ocean, almost like using two hands, like you're clawing up the screen. You have one ocean, you're going to get the second ocean, the second ocean, and the second ocean, and you're going to keep doing that forever. One thing, the reason why you want to do this as well is when we do longer scrollable areas. For example, when we do I'm going to try and show you guys a parallax scroll when we do our platformer. I might have several layers of scrollable backgrounds. The front layer, maybe several middle layers, and the back layer. And all those layers are going to move at slightly different speeds. They're going to reset at slightly different speeds. So they're going to kind of move this way, and then you're going to have something that looks like this for each layer. They're going to crawl to the right, or they're going to crawl back to the left, or they're going to crawl up, or they're going to crawl down if you want to have pure, four-directional support for your map. So that's what these things will do, and it's good to learn how to do multiple oceans. Okay, but we have one ocean, right? And we have this game object. Again, I can make this into an ocean as well, but the right thing to do is let's just delete this thing. And let's make this ocean into a prefab. So prefabs, the way they work are, think of them as instances of a particular object that I've defined. So I define my object's behavior with the object. I can configure it here in the inspector, step one, and I can also configure its behavior in a script, like for example the ocean controller. And I want these two things to be replicated every time I pull a prefab of type ocean into my hierarchy. So I want two oceans now, but there's going to be a problem, and I want you to think about what that could be. So here's my prefabs. I'm going to drag and drop my ocean from my hierarchy into my prefab. Yay. Done. Okay, now what I want to do is I want to drag my ocean again back from my prefab into my hierarchy. So I have two oceans. Well, okay. But what I want is like one ocean to be staggered away from the other one. So my first ocean, this one, and then there's my bottom ocean. And I can actually mention this, top and bottom, right? Or first and second. Let's just leave it like this too, that's fine too. let's move this one so it's offset from the other one, like this. So let's suppose my other ocean starts at the bottom. And by the way, if I want to get my ocean to exactly connect with the bottom, what's a quick way of doing that? Does anyone know how to do that? I want to make sure that this texture connects with this texture. Really, like almost like snaps too. Does anyone know how to snap the texture together? Sorry? The what?
It's like having it interfering or...
No. You could do it that way too. Hold control and move it. Let's try. So hold control and move it. It snaps like this, but it snaps to different positions, not necessarily to the texture. Look, it's actually, if you zoom in, look what it is. It's actually missed, right? So there is a way of snapping. If you press V, here's the way to do it. If you press V, you can do something called vertex snapping. So then that connects to the texture immediately. So that's perfectly fast. And notice on the right, it's negative 9.6, and my ocean is at 4.8. So this ocean starts at negative 9.6, and this ocean starts at 4.8. Here they are. So I have two oceans now. Okay, but this isn't going to work. This isn't going to work because this ocean here is going to reset now. Well, remember what my reset is. My reset position, right, is here. This is where it's going to go. And my reset point is negative 4.8, which is here. That's where my reset point is. So this thing that we got going on is not where this ocean part is, and this is not where it's going to be. I would like it for it to reset here. So this part is where my ocean should reset, so down in here. So this point, if you will, it should reset off screen, not on screen. So it's going to go down here, and then what I want is for this one to, when it gets to here, to reset up there, and this one to keep going. Alright? I can do it that way, and there's other ways to do the same thing we can think of. So the reset point now, the reset point was negative 4.8, which is where this one is kind of now, negative 4.8. But actually what I want is for the reset point not to be that anymore. Negative 4.8. Negative 4.8. It's not to be there anymore. It's actually, I want the reset point to be here when it gets to this point, which is negative 19.2 actually. And if the way to see that is if I take the vertex snapping thing again. So vertex snapping, I want to snap it to negative 19.2 is the new reset point. So when it gets to 19.2 at this point here, that's the time for it to go back. But where should it go? When it hits 19.2, it should actually go back to here, which is at 9.6. And I can show you that, but if I press V snapping again, it'll go 9.6. So 9.6 and negative 19.2 are the other values now, the reset positions. All right, let's try that. So again, reset position 9.6, reset point negative 19.2. And I need to apply this to the prefab. I can't just do it for one of them. I have to do it for both oceans, and I don't want to duplicate. What if I had 20 oceans or something crazy? I don't want to do it for each one. So if you look over here on overrides, the new prefab system for Unity 2019 works like this. I'm going to click overrides, and notice that it says the ocean controller script has changed. I'm going to click apply all, and what's going to happen is that all of them are going to have this 0.1, 9.6, and negative 19.2. If I click this one, you can see that's already done. So the reset position is 9.6 now for each of these oceans. All right, let's put them back to where they're supposed to be. So again, we can see that by default, what I want is for this one to start down here. But we're going to have a problem. What do you think that problem is going to be, guys? Negative 4.6. Anybody? negative 4.8 actually, negative 4.8. And this one is negative 19.2. Can someone tell me what the problem might be? Come on, can you guys discern? You guys have, how about the people who have more experience? Josh, what do you think the problem is going to be when it comes to this thing? I've created 2 ocean prefabs, right?
Yeah.
And both of them are using the same script. And in the start script, you know, I get them to reset. What's going to happen?
Well, if they have to reset at the same time and they're not, and the top of one image doesn't perfectly go into the other, then it still won't be as fluid a transition.
That could be one thing, but the real problem is that because I'm resetting both images on start, that both of them are going to be right on top of each other.
That too.
Let's see what happens. Let's see what I'm talking about. Watch this. So if I press play and then immediately stop it, well, see what happened. They both slammed into the start position first, and then they're going to continue to go down and be together the whole time, like together. I don't want that. I want them to be offset. So how do I create that offset? It's almost like if this is the first time, and only when this is the first time, I want you to ignore the default position, right? I don't want them to reset on start, right? I could, the easiest way of course is to go to the script. So here's my scripts. I can go to the script and just, on start, just take this reset position out. I mean, I could just comment it out, right? That's one easy way to fix it. And whatever these positions were, right? So here's where I want them to be, right? So again, if I was to do this properly, it's going to start like this. So this is the top ocean. And this is the other ocean. And this is going to be at, again, 9.6. So here's 9.6. This is I would want to start them somewhere like this. And this would be vertically snapped to the other ocean. So I can say vertical snapping by pressing the V key and moving it up. And this is negative 4.8. I could start it like this in the hierarchy. And then I can press run. And let's see what happens now. Well, you can see it's moving together, all right? And if I go down here, you can see what's going to happen. Now we're going to get something that looks like this. Now I've clicked on, it works, right? I've clicked on, take a look at the one I've clicked on. That's the bottom ocean. So you see the bottom ocean goes down here, keeps going, and then resets to the top. And then keeps going, follow this one. Keeps going, and then resets to the top. And it's doing exactly what I want it to do now, right? As it keeps going, it moves to the top. And it keeps moving all the time. So this is what it actually looks like now. But there's still a bit of a problem. You can still see the seam, right? I mean, it's just the way it is. And you can see the seam because the seam is moving through the viewport. It's moving across the viewport as the seam is going. So there are other options here where you can reset the seam before it actually moves into the viewport. You can reset it. Some other kind of interval. But this is fine for our purposes. Now, one of the challenges we have is this. Sure, I want the oceans, as an example, to start with a hierarchy. But what if I was to give you this project, and I gave you the ocean prefabs, right? And if you wanted to use more than one ocean, well, the problem with that would be that you wouldn't know the start position. There is no start position for the oceans by default, right? Because I haven't set that up. I haven't set it up with a script. And I could use another script for that. I could attach another script. That's one trick that you could use. So you say that with this one, whenever this starts, it overrides, the start position on start. It starts this position. On the other one, it starts it at the other position. And so I can make a variant of my prefabs, top ocean and bottom ocean, or whatever. But it's kind of overkill, especially for this little job. Okay, cool. So why did I do this? Why did I reset this ocean in the first place? Couldn't I have just made a massively long texture that's like, that would last like 5 minutes and just keep scrolling through it? I mean, I could, but why wouldn't I do that? And guys, I'm just talking about this because, just in case you have these wild ideas, let's just make a massively long texture that lasts 5 minutes and I don't have to scroll at all, huh?
Why would you do that?
Well, here's why. Here's the pros of doing that. If I made a really long texture, it's almost like I'm making a level that I'm going through. So this level would be very, very long. Like maybe it would last 5 minutes. So it would be a long texture or a series of textures that would be kind of connected together. And basically what I'm doing is I'm moving through a particular place. Like some of those old action games where you see some other items that appear in the background. You hit land and you hit other things. I'm saying.
Actually different, like when you go through, let's say the first mission, but
Yeah.
it's the same going back.
If it's the same, if it's the same ocean, like blank ocean, that makes no sense. But what if it's completely different? Then it makes sense for that to happen somehow. If you want to show a different texture for 5 minutes, right? I mean, it's pretty long though. 5 minutes would be like a massively big texture. You got to figure, especially how fast we're scrolling. So that's one thing. So here what we're doing is we're reusing our objects. We're reusing our stuff. So memory management is low. I don't have to instantiate new objects. I'm going to keep the same two objects working in the hierarchy the whole time, which makes it more manageable. And so I want to use the same methodology for the rest. I want to add other objects to the viewport in the same way. And what I want for them is for them to scroll the same way. They have a similar way of doing things. Now, when I start saying the same way, in my mind I'm thinking class. If I want something to do the exact same thing over and over again, right? And I want other objects to do almost the exact same thing that those objects are doing, it's almost like I need a scrollable class, something that scrolls. And if I want to go there, and we won't do it today, I want you to think about what that scrollable class would be like. It would have boundaries, bottom boundary and a top boundary, a left boundary and a right boundary. So it would be more generic. It could work for any scrolling direction, not just the top. I would have the ability for me to direct it. I want to move towards the right. I want to move towards the left. I want to move different places. Here's another option. Could I not scroll the camera instead? I mean, right now I'm scrolling the entire world behind of it, right? The entire world is moving. I mean, could I move the camera instead of scrolling the background? And what would be the advantages and disadvantages there?
You can do that, but your characters and everything else.
I mean, I could make the character follow the camera, or the camera follow the character, huh?
How are you going to control your character?
Maybe with a keyboard command. But what I'm saying is I could make the character move around the world and not the world move around the character like it's moving right now, right? So it's another option. And actually in our platforming example, we're going to see that the platform that we're going to create is going to be a certain length, and we're actually going to move the character along the platform, and the camera is going to smoothly follow the character across the platform as it moves across, right? So the camera is going to bound across the platform, not the platform's not going to move towards the character in a platform. Here we're making a scrollable game, an endless runner almost, if you will. Whether I'm a top-down or kind of a side scroller, it's running forever. I want to do the same kind of things now for the other objects. I have a cloud object and I have a island object. First of all, before we go there, you know what? This is a great place to put it up on Collab. We've added our ocean object, and let's put that up. So I'm going to say Collab, and I'm going to say added ocean game object. That's what I've done. I'm going to click publish now. And this is going to publish my changes up on Collab so I can always revert. This is almost like I've added a feature. My scrolling background works kind of thing, right? And, if I was going to be a stickler, this is a great place to put it up on GitHub too, because I've added a feature, right? So let's close it down. And then I'm going to go back to Git Kraken, right? And what I can do is I can view changes. I have 6 files that I've changed. You can see the textures that I've modified, the ocean prefab, meta, and so on. I can stage all the changes. I can make a commit message. I can say that added ocean game object, and then click commit files to commit changes to 6 files, and then I can push my changes to GitHub, and then we're good to go. So now GitHub has my changes too. Great. Let's pull Unity back up. Now you're going to see this as a bit of a workflow pause. I've done something with Unity. you know, I've put it up on Collab, I've put it up on GitHub, and I go back to Unity again. And you're like, wow, if this has to happen every single time, right? It's pretty crazy. So we'll do one more and then we'll take a short break, okay? And we'll come back. So let's suppose I want to do the same thing for my island. Well, my island, first of all, how fast is my ocean scrolling? Is it the right speed? Does it look right to you? I mean, it could very well be. I don't know. I mean, the thing that you have to consider is this how fast you want your ocean to go? Is this too fast? You know, should it be slower? I don't know. But if you want to check it out, again, what we talked about is this. I can go to both oceans, and now I have control in the editor of my vertical speed. Let's just drop this down to 0.05. And now you can see that the speed is slower. You might get a few artifacts when you do this, like that. See that artifact? Which is kind of a division. You didn't see it here, but you might see it again up here. Why? Because I'm mucking with the editor in real time, and sometimes you get a weird dividing line. But you can see maybe that's a better speed, like 0.05, which is like 5 pixels per frame, equivalent. So if that's true, I can copy this number in the real-time editor, go back, and then paste this number in for both objects inside the hierarchy. And once I've done that, we're good to go. Now it's going to operate, the next time I run this thing, it's going to operate at 5 pixels per frame, which is probably around the right speed. Okay? I don't like that. That's a weird thing. We noticed that last time, whenever we did it, we have these really weird glitches. Take a look at this. So, shouldn't happen ever. Like right there. See that? Take a look at that. That's like 9.6, and this is negative 4.8. They're all moving at 5 pixels per frame. So why is it, do you think, that I'm getting these weird glitches when I add vertical speed? Anybody? Some people said, well, maybe it's floating point calculation error. Could be that. And I'm like, could be. How about the fact that my update isn't a fixed update? That means sometimes you have a separation between one object updating and the other, slightly. And enough so that one object moves a pixel or two faster than the other object. That can happen. So to mitigate this, if I want to, I can go back to my ocean controller. And again, this takes up a little bit more cycles than the other thing is. Instead of calling update, let's try calling fixed update. And fixed update, again, usually used for physics, but it might be the right thing to do for us here. Let's try this out. And if I press run now, maybe we'll get a better result. Maybe. Let's try this out. Now you can see immediately that I took a hit performance-wise. Take a look, because that's what fixed update does. Fixed update. Oh, I got the error anyway. Fixed update is a lot more harsh on my system. You see it? See how it's jittering more? Fixed update requires more horsepower in general. Okay. Now I am running in the editor, and I want you to think about it. When I'm running in the editor in Unity, I'm running in debug mode. In order for me to run this properly, I need to run this in release mode, and to do that, I have to build my object, my project. So anyone ever built their projects? Yes, kind of. Let's really build it. I'm going to build it for WebGL. All right. Remember we had the WebGL build last time, and you can see that that'll be built. Built means it's completely it's created a binary, and now it's running from a binary file, not in the editor, live in the editor, which means better performance. So if I go to File, Build Settings, right, you can see now that by default we're targeting PC, Mac, and Linux standalone, right? Notice also that if I go here, and if I go to player settings, there are some optimizations. Let's take a look at the optimizations options here. So a couple of options. One, my company name. Well, let's put Centennial in there. You can put whatever your company name is, right? Here's my version, 0.1. It talks about my resolution and presentation here. So right now my presentation is going to be a full screen window. I could also make it start off as a a windowed system. So it starts as a window by itself. Full screen window is okay. But notice that right now, I'm not targeting WebGL. I'm targeting PC. If I want to target WebGL, I need to switch platforms. So I'm going to click on WebGL, and I'm going to click on Switch Platform. And what this does is it does some pre-building and recompile scripts so that it's compatible with my new platform. By the way, if I was going to do this for Android, it might take a while. Okay? Although Android is not an option. Okay, next. So this is the first part. What was that? Yeah? What? Yeah, oh yeah, I can do that. But I'm saying it's not. I just haven't added the Android, option in there as an option, right? So if I go back to my player, notice that now instead of looking at this tab, I'm looking at this tab, which is WebGL. Here's my resolution. My canvas width is 960 by 600. That's no good. It should be the same size as my game, which is 640 by 480. So that's the first thing I want to check. It says run in the background, which it would run in the background. I can define a splash screen. So I'm just going to make this a little bigger so we can scroll. I can define a splash screen if I want. Here's a splash image. I can always go to other settings, and this is where it becomes interesting. My color space is gamma, and there's a bunch of other options that I can use for optimization. Notice my API compatibility level. It's .NET Standard 2.0. I can always go to .NET 4.0, which is actually a better compatibility level. However, when I do this, my project would grow in size quite a bit. Right, so I'm going to leave it the way it is. Compiler configuration right now is release mode. That's the default. Right, that's my release mode. So that's what I want. And that means when it's compiled, my C++ compiler is going to run my program in release mode, which is way faster than in debug mode, which is what I'm doing when I run in the editor. Okay? If it says I allow unsafe code, that allows me to use things like it says, assembly, C#, DLL, pointers, blah, blah, blah. If I click this on, it'll allow me to do that. It also asks me to do things like, from an optimization perspective, if I had collision data, I could pre-bake those to make it better in terms of performance. I'm not going to do any of that right now. From a publishing settings perspective, it also tells me how I want to publish everything. If I'm going to publish it from a gzip perspective or some other method, and so on. From a WebAssembly perspective, do I want to stream this thing or do I want to create it? Because by the on the back end, it uses a method to convert C++ into JavaScript. Okay, so we're ready to go. We've got our player configured as best as possible. I'm not touching the other settings yet. There's a lot of other optimizations we can do in here, but we're not going to do that right now. And I'm going to build and run. What this is going to do is we need to create a folder for my build to live in. And so we're going to make a new folder called builds. Now remember, in our gitignore file, we're ignoring the builds folder. It's not going to go up on GitHub. Okay? Let's do build and run. So it's going to ask me what folder do I want to put it in. I'm going to make a new folder called builds. Now this is going to be a local folder that's not going to go up on GitHub. And I'm going to click select folder, select this folder, and that's the folder that I'm going to use to build my code. Now it's going to take some time. And right now what's happening is it's compiling, linking, and building everything, so it's going to run in release mode, not in debug mode, which is the preferred way. If you're running a demo for a company or in a professional setting, for the most part you want to try not to run it in the editor, all right? Because editor can be a little bit slower. However, and this is the funny thing that happens, it might work in the editor, and when you run it in release mode, it doesn't work at all. That's a problem, and usually it's because there's some kind of breaking change or some kind of bug that you haven't addressed that needs to be fixed. Okay, so this is still building. Notice it says IL2 CPP. So what it's doing is actually it's converting, from C# into a C++ version that's kind of like a bit of a data chunk that we're going to use to connect to WebGL. So it's going to take a bit of time. Now again, you're going to say, wait, Tom, it's your computer, you're slow. Yeah? I don't think so. Right? It can't be the computer, it's just the process that's working here. Because my computer, again, like we talked about, isn't so bad. It's a 9.9, it's got 32 gigs of RAM, and I got a 1080 with, you know, with a terabyte SSD. So I'm not sure how bad that is, right? Maybe you can get a GTX 2080 and that might be better. Or maybe you can run this compilation on the GPU. But for now, this is probably good enough.
The only thing you can do to get better is go desktop.
Maybe desktop would be better, yeah. And I agree with you. But so you can see that this takes quite a long time. And that's why whenever you do a build like this, and on a test, guys, this is really important. I'm going to ask you to do a WebGL build. For you to wait on a test for this to happen, you want to not do this until you're ready. Until you're ready to build it. And that means you tested everything locally, it works great, and now you're going to do the WebGL build closer to the end, not exactly at the end. Okay? Here we're compiling the WebAssembly module, and what it does now is it uses WebAssembly in order for it to be read, which is something new for Unity. And as soon as this module is created, it basically creates a runnable index.html file that if I double click, I can run anywhere. In fact, like I said, I can take this information and put it on a web server somewhere, right? Did I say that? I can put it on a web server somewhere. Hell, I think I already did. Let's see. Let's go to my, if you look at my lastname.com, right? Yeah, I know. I'm one of those guys who bought my last name. No, not .com. Let's just see if it works still.
My brother went and bought a few different.
And you can see that this is the completed version of what I want to build with you guys, right? But this is actually running in JavaScript, right? This is what the JavaScript version looks like. And you can see that it's going to be very similar, right? So if I start the game, it's going to make noise, and I'm not going to do that right now. But basically, if you want to try it yourself, you can go to this link and try it. I'm going to do the same thing with this version. Notice that this is asking me to run it. I'm going to allow access, and here it is. There's an example of this thing running. But we still got that problem. See that? That is an issue. Now we've tested it both in the debug version as well as in this version. So what's a way to mitigate that? Like, that's a problem. That's like, look, there's a seam. It's terrible. Like, it's ugly, in fact, right? So on this side, it's okay, but on the other side, not okay. Not okay, guys. That is like terrible. And if I saw that in one of your tests or your assignments, I'd be like, no, you got to fix this, right? So what to do? Why is it like this? What do you think? Any thoughts around that? Yeah. Not actually joining, okay. And notice the jitter. Like, that's a lot of jitter for a website.
Is it like a few pixels?
A few pixels is off. It's off somehow, but only on one side. Look, see, it's off there. But only on one side.
The speed of it,
Yeah.
maybe like one is slightly ahead.
On the other side, though, it's fine. Now, see that side? It's okay. But on the other side, sometimes, every other time, it does this. Right? It's a glitch. It truly is. Right?
There's no reason for it?
Well, there's a reason. Let's go back to this part, right? Here's the code. Here's the code. So I tried fixed update. That didn't help. It actually hurt to do fixed update. So we're going to go back to update. That didn't really do anything. Well, let's take a look at our code here. I'm saying, okay, 4.8, and the reset point is negative 4.8. Okay, cool. Negative 4.8, no problem. And then I'm saying, okay, come down here, and every frame check bounds. Again, from a coding perspective, this method checks if the ocean reaches the lower boundary, and then it resets it. Okay, so that's kind of like the comment. That's what this function does. We move and check bounds every frame. Move and check bounds. Move and check bounds, and we do this unrestrictedly at least 30 to 60 times per second, because we don't know what the frame rate is right now. Okay, so that's one thing. These three things are public objects, again, all we have is these two oceans, and the position of this one is 9.6. And if I zoom in here, you can see that they're absolutely connected. This one is connected to this one. I can even do vertical snapping here to make sure. Right? So again, even if I was to move this thing away, so let's move it away. And I can show you that. Right? There we go. And I'm gonna scroll in here so you can see it. And the way vertical snapping works is if I hover over the vertex here, vertex snap, you can see it's on the vertex, and if I move it up, boom, it snaps. So negative 4.8 and 9.6, I mean, it's touching, guys. It's touching. Now, the reset point we say is at negative 19.2. Does that make any sense? So it goes back to 9.6. This one starts off at 9.6. And this has to reach 19.2, negative 19.2 in order for it to reset. Does that make sense? Why 19.2? Is that the wrong number? It works, so it doesn't seem to be the wrong number. But what is negative 19.2? Well, here's this lower ocean, right? So here's the lower ocean. Negative 19.2, again, let's just put that in there, is here. There's negative 19.2. And this is going to follow, right? So here's the following part. So this is going to go down, and this is going to go to where the other one was, which is here, at negative 4.8. Negative 4.8. Okay, what happens down here? Are they connected? So there, you can see that it looks pretty good, right? They're on top of each other. And let's just move this one away so we can see that as well, so that we can vertically snap. I want to see what the difference is. And then vertex snap, whoop, 19.2. Seems to be right. What could be the problem? I have the answer. It's not pixel perfect. It's not. You're going to get errors. And also, what's happening is my vertical speed is 0.005. Right? 0.005 is a weird number. And it's trying to add that in. And if you watch the game run, take a look at this, the value of my ocean. I mean, if it's moving down 0.05 every time, that means this number here should be, you know, I don't know, intervals of 0.05. Is it? Let's see. So, take a look at this number over here. What's happening down here? Look at that, look at that, look at that. Where are those numbers coming from? I'm not adding anything less than 0.05. How come I'm getting that weird error? That's a lot of error, guys. Like, it's like that little error is causing the separation. You see it? Should not be. It should not be. So that's what's causing the problem. It's not here. It's because my vertical speed is actually a floating point, and I'm getting a bit of a floating point error. That's what's happening. I'm not sure if it's a bug with Unity 2019 by .2.4F1 or what, but that, we're seeing there shouldn't happen. Anyway, let's move on. I'm going to ignore it. If I move faster, though, let's say if I go to something even, 0.06, right? And I'm going to do that for both objects, 0.06. There we go. Now let's try it and see if we're getting an error. Yeah, look at that. But we didn't seem to get the error when we moved to 0.1. When I moved to 0.1 for both objects, it wasn't noticeable. It was so fast, well, except for there, it was so fast that we wouldn't notice it anymore. That's how we saw it. Now it's popping up all the time. What could it be? We didn't change anything. Truly, we didn't do anything. It was different. So, what was that?
Can you just overlap them a little?
But then I would have a bigger gap somewhere else. If I overlap them in one place, What is it going to look like on the other side? I have to unoverlap them? It's pretty crazy, right? So again, we're trying to fix a problem. That's what we're trying to do here, but we're actually creating a problem. So just keep this in mind. Sometimes, things don't run exactly as expected, and you have to try and fix them. Sometimes it's just Unity needs to be reset. I'm telling you, this is a glitch. I've run this stuff for years. I never had this problem. So either my coding is wrong, something I put into place kind of on the coding side, which I don't see how because I'm not doing anything. 4.8. And here I'm 0.1, but all I'm doing here, the only difference is that I'm doing this. Move is negative equal to new position, where new position is equal to vertical speed, right? Hey, if you really want to put this for what it is, this is a vector2 object transform that's equal to transform.position. It's getting the position value from this, right? If you really want to be more specific than this, when I make my current position, I could say that my current position, I could build a new vector for my current position to make it more accurate. So instead of trying to get a reference to this object. So let's suppose that that's the problem. Let's do some corrections. So I can say something like this. I can say this is a new vector2 object, and my x and y coordinates are my transform coordinates. I can say my transform, this is really crazy, dot position dot x, and my transform dot position dot y. So I'm not directly getting the current position from my transform. I'm just getting my x's and y's from there, right? Whatever those happen to be, right? And then what I do is whatever those values are, I subtract from my new position. And I'll tell you guys, even if I did it this way, you're not going to see, potentially you won't see a difference, you see? So it's not that. That thing that I did, which was minus equal, I mean, sure, you could do it this way too, and this minus equal, this overload, is really what's happening is what's happening here. I'm taking vector, I'm using the operator overload, the minus operator overload, and taking vector A and vector B and subtracting one from the other. That's what minus equal does. So that's not it. Yeah.
You were literally just saying sometimes just restarting Unity type of position.
Yeah.
I know the last time you closed it was when you uploaded it.
Yeah, let's try it. Sure, let's try it. Sometimes, I said. Sometimes. But sometimes, this seems to be, even when we built it, it still had a problem. It still glitched out, right? Which is kind of a weird thing. Shouldn't happen. Like, this code isn't terribly bad, right? What was that? Maybe. Well, I'll try it at home. Okay, I'm not going to try it here in front of you guys. So let's just ignore it for now. We know there's a glitch. I'm going to fix it for you guys. Don't know why. I'm going to close down Unity though and put it up on GitHub because I think we've got to a point where it's working the way I'd like it to work. And I've also built it. So I'm going to kind of save everything. I'm going to go back to Gitkraken, right? Which is here. And we know that there's a bit of an error. One thing you can do is you can log an error. So I can view my changes. I have a couple of asset changes that I put in. So here's my scene. We changed the ocean controller a little bit. We can stage all the changes. If for my commit, I might say, detected a separation bug. Separation. Sure. Let's see if it does. Okay, so there you go. So that's thing. Now let's open it back up and add in the next option. But you know what? Before we go there, we have about an hour or so left. Let's take a 10-minute break so you guys can get a bit of a water break and a bio break and come back, and then we'll finish off with a couple of additional objects. So I'm going to stop recording now.
Did it upload? Because it still shows the 25 minutes ago.
What?
That you last uploaded.
I uploaded it now.
still says updated 25 minutes ago.
There you go.
Did you forget to press push?
Probably. So that's what happens when you use a tool.